Good evening, my dear students. Once again, welcome back to the last class. Okay, last class of the 9th standard chapter called as the motion. Okay, it is the conclusion part. We will conclude the entire equations regarding this graphical derivation of these equations of motion. Okay, how you want to perform when questions comes for examination. Okay. Here this is Mithun Raj, your science teacher, signing in from this part of the world, Cochin, Kerala. I hope all of you are fine, feeling healthy and happy anyway, isn't it? Okay, anyway, this corona time and all, it will soon, we hope that it will end and fresh days, older days will come, the days of enjoyment, the days of joy and all. Okay, let's hope for the best. But anyway, class must continue. Okay, whatever happens, education must continue. So we can begin with the last part regarding this chapter called as the motion. And the most important part of it is a 5 mark essay. It is the graphical derivation method of these three equations of motion. Okay. Anyway, you want to by heart these three equations of motion. You already know to derive in the mathematical method. Okay, simply by substituting each variables here and there, you already know that. That's a bit easier part. But in this graphical method, actually graphical method is the real easier part regarding that. Okay, so for exam, what you want to do, we will just study now. So which graph we are using for this purpose? You have studied about a lots of graphs, and all those graphs are also one or 2 mark question. Okay, mostly 1 mark questions comes from that part. All the graphs, this at acceleration time graph, distance time graph, speed and all graphs are important. But the most important part is the derivation of equation, these three equations, and why this velocity time graph is more important. You already know that, because the area under that graph gives what? Gives displacement. Okay, when we get displacement when a graph from a graph which already have velocity and time, we can easily find out all the variables we need. Okay, we can find out acceleration, we can find out the time, we can know the distance or displacement, we can know the acceleration, and all these equation is being solved. Okay, after that, after this class, I'll give some numericals for you to solve, some easy numericals. Okay, try to solve, just substitute these equations. I think numerical solution for the first part is easy, and if you are able to solve it, please send it back to me as a message. Don't write it to the notebook. Okay, first I will check it is correct or not. After that you can copy it, and you can add that with that note which I have already given you. Textbook solution also after that I will give. There's a lots of numericals in textbook. Refer that also. You can directly write that to your science notebook. Okay. So let us start. So which graph we want to take? We want to take velocity time graph. Actually, this is not the graph. This only x-axis is there and y-axis is there. I think this is turned wrong. X-axis is here and y-axis is the upside. Okay, let's see. Okay, you already know that. I have to fix it. I will fix it here. Okay, I hope you can see these things. Okay, first, how to draw the graph? How? You already draw that graph 2 or 3 times, but still, from the beginning, how to draw it? Like a sentence, how to draw a graph? First, what do we want to find? We want to find the velocity here. So we know that anyway, when there is acceleration, there will be 2 types of velocity. Okay, regarding time, time is what? We cannot, independent of all those things, we cannot change the time, isn't it? Let us see. So we already know that in x-axis what we will take? We will take independent variables, which is here time. So time already I have written here, and in the y-axis we are taking what? We are taking velocity. So we already know 2 types of velocity will be there if there is an acceleration. So in first case, let this point O, when the time is 0, at that time what velocity is there? Initial velocity. Let it be, just assume that it is here. Okay, And that point what we want to write? Okay, we can write it as P. Okay, and this velocity is initial velocity which can represent as U. Okay, so this distance OP is the initial velocity and we can represent it by U. And just we are taking some time like 5 seconds or 10 seconds. Okay, just see, like from here I am taking this point. Any point we can take, no problem. And this point, what do I want to mark? Okay, I will mark it as R. Okay, this is R, this is O, this is P. At this point, we get the final velocity, which I will mark almost like straight line here. Okay, so this I can mark it as what? Mark it as N. Okay, so these are the two velocities we got. And in velocity time graph, how we can show that time relation between that? Just drawing by a straight line. Okay, actually this is the velocity time graph. You already studied that. But we are making some extra variations in this graph so that we can solve it. Okay, we need to find the area. So just join these two lines. Okay, not a straight line, but this is the area, and what is that? That is displacement, isn't it? This entire area will give us displacement. But how to find the area? What shape is this? I think it is a trapezium. I think you already studied to find out the area of a trapezium. There's a particular equation, isn't it? Add the parallel sides and multiply it with the height. Here we cannot say, actually this is the height here. Okay, the time T is the height here. Actually we want to take the trapezium like this, then we can say that the height. Okay, anyway this side opposite perpendicular to the parallel side is also taken as height. So that is the equation we want to use. But two types of equation we want to solve. We want to solve not 2, 3. 1, 2 and 3. So let us start with the first equation. So what is this measurement? This is the entire length is what? U. Sorry, V. So this is the initial velocity, this is the final velocity. So how to solve it? Anyway, you know that it is easier to solve when we find out the area. So let us start with the first thing. Just join these two lines. Okay, here. Okay, here what we get? That line is Q. So now we got two geometrical shapes. One is a triangle and one is a rectangle. And the rectangle means OPQR and the triangle is PNQ. So from here we can say that OP is equal to what? OP is equal to, say, U. And what is RN or NR? NR is what? NR is V. But again one more thing is here. What is OR? OR is the time. Time. So we got velocity, initial velocity, we got final velocity, we got time. So easily we can derive what? Equation for acceleration. Acceleration is final velocity minus initial velocity to the time. That is, what is the initial velocity? No, final velocity NR minus OP divided by what? Divided by OR or P, whatever we can write, OR. And just substitute these terms here. Okay, substitute these terms here. A is equal to, what is NR? V. What is OP? U. V minus U by T. From this equation we will get what? We will get the first equation, that is AT is equal to V minus U. Again we can write the final equation, V is equal to U plus AT. So that is the derivation of first equation, and that is very easy for, isn't it? We no need to find the area here because the first equation there is no what? Displacement. The second equation we have, and the second equation, wait 1 second, that is regarding what? That is regarding displacement. Okay. In that, how we need to find out. So we know that what? The area of this entire section is the displacement. So just what we want to do? We want to do the, find out the area of this rectangle and the area of this triangle. Just add it. The total area will be displacement. Let's see. So what is S? Here S is equal to area of the rectangle OPQR. OPQR plus the area of triangle PNQ. So you know the equation for the area of rectangle. What is it? Okay, length into breadth. What is the length here? OR. What is the breadth here? OP. So which is equal to OP into OR plus what is the area of a triangle? Half BH, half into breadth into height. Half into what? PQ into QN. PQ into QN. Understand? So now what we want to do? You want to go for the graph and you want to substitute the values of each term. Okay? Value of OP is what? Where is OP? OP is U. Is equal to U into OR is what? Where is OR? OR. Okay, OR is T time plus half is half anyway, isn't it? Into what? That is PQ. PQ, where is PQ? PQ is also what? PQ is also C. This is same, isn't it? OR is equal to PQ. In it out. This is also what? This is also time. Okay. Means where T into Qn. And what is Qn here? Qn, what is it? We know that the entire length NR is what? V. If we substitute NR with OP, what you will get? See, this much is NR, this much is OP. If we take down OP, what we will get? QN. So what do we want to do? So NQ is what? V minus U, isn't it? This length is V minus U, and NQ directly we can substitute here V minus U, isn't it? So what we got? We got ut plus half t into v minus u. But what is our equation? Our equation is s is equal to what? Ut plus half at square. From at square, where we want to get? So v minus u, we already know what is v minus u. Come here. What is v minus u? V minus u is what? V minus u is 80. Just cut it down and put it at. So what we will get the final equation? S is equal to ut plus half t into at, t into t square, at square. Got it? Got it or not? Just whenever you are writing an equation, just make it a square. Actually, it's not, you won't get any extra mark, but it looks good. Okay, that's the scientific method to represent equation. Just put a square. Not with reading, only with your own ink. Okay, that is the second derivation. Understood? S is equal to ut plus half at square. What we did? We just find out the area of the entire, not entire square. First we find out the area of this rectangle, and next we find out the area of the triangle, and we just add it. Or before adding, we just substitute the terms from that graph, and we get which equation? S is equal to ut plus half at square. So let us go to the last part. This equation we want to get v square minus u square plus equal to 2as. But if we do this in this form, we won't get. So in that method what we are doing, we are going to find out the area of the entire shape. So that is the area of the trapezium. And the area of the trapezium is what? Half into, that is S is equal to half into, add the parallel sides, okay, OP and NI. This is the equation of trapezium, okay. I hope you already studied it in geometry. The addition, add the parallel sides, multiply it with the height divided by 2, that is the area of that trapezium. So which are the parallel sides here? This and this side is not parallel, okay. Leave this line, okay, leave this line for this solution. Anyway, this line and this line is not parallel. Which are parallel here? OP and NR are parallel. So we have to add it, OP plus NR, OP plus NR into what? Into this one, height, okay. Let's see, it is R. So now what we want to do? Just substitute these values. So we will get S is equal to what? Half into, what is OP? OP is U. And what is NR? NR is V. So OP plus NR means V plus U. Into what? OR is what? OR is the time here. So we got the equation. Did we? No. U square minus V square minus U square is equal to 2AF we need to find. We have V plus U, we have half, we have S. But where is A? We don't have A. But from this equation, what we will get? T. Substitute the value of T. T is equal to V minus U by A. Is it correct or not? Just substitute this value here. In the name in the place of T. What we will get? S is equal to V plus U into V minus U by A. V minus U by A. 2 is here, so it becomes 2A. Isn't it? Send this 2A here. What we will get? 2AS is equal to V plus U into V minus U. Which is what? V plus U into V minus U is V square minus U square is equal to 2A into S. Is it correct or not? All the three equations are solved here. Understood? So this is not the final equation. The final equation is what? 2AS plus, I will just show it here. There's no space, that's why. Come here, one more pin. Okay, see. V plus U into V minus U is what? V square minus U square, which is S. But 2A will go here to give 2AS. So this is our final, our third equation regarding what? Regarding the motion. Okay, that's the solution. One more time I want to explain. I hope you all understand this. Okay, one more small part is there, that is called as circular motion. It's a very small part. We will explain it in this class itself. Okay. Come on, just remove it. I hope you already understand it, isn't it? One more time we can just go. So we know this is the velocity time graph. Only this slope is the velocity time graph. And we are modifying it because we know the area of this particular section is the displacement. So first equation directly we are getting. Okay, substitute the value of V we have, U we have, T we have. If we have a velocity, if we have time, we will get acceleration. So first equation we already solved. Second one, we know the area of the entire that diagram is the displacement. From that we will get two areas, one of this rectangle, one of this triangle. Just add it together. We will get what? The total area of that figure, and which becomes S is equal to UT plus half AT square. Next, one more method is there. We also know the equation to find the area of a trapezium. Half into, add the parallel sides and multiply it with the height of it. Here height is T, parallel sides are OP and NR, which is V plus U. We can do it here. Substitute the value of T from this equation, V minus U by A. Directly it will go here. V minus u by a. Multiply v plus u to v minus u. Already studied in mathematics. It is v square minus u square. Take the 2a to this side. It becomes 2as is equal to v square minus u square. I hope all got it. Okay. Anyway, notes and all. I will give three numericals. Okay. Today I will give two numericals regarding this equation. Okay. The first equation. Just try to find it out. Tomorrow, then after that, just answer it to me and send it. Take a photo and send it. If it is correct, I will send. Write it into your science notebook. Okay, directly don't write it because there is a chance you will make a mistake. I can just remove this part and we can study what is circular motion. Okay, here it goes and here the next paper comes. How many of you know how to draw a circle? Just by a compass you can draw, but I will try to draw without a compass here. Okay. Okay. I think it is a circle. The circle will have a center. So uniform circular motion or circular motion means any motion which is in the circular path. A very good example we have. Anyway, the revolution of our earth we can say, but actually it is in an elliptical path, not the circular path. But in the case of circular motion, uniform circular motion, okay, uniform circular motion. Okay, maybe the motion is in this direction, and here what is the displacement or the distance? The displacement is 0 here, is it? Displacement is 0 because it will start from one point and it will end in the last point. But what is the total distance traveled? It will be the circumference of this circle, isn't it? Just imagine this is the radius r. Okay, radius of the circle is r. So total distance is what? The circumference. That means how will you find speed from that? Total distance divided by time. So the speed, you can represent the speed by what? Speed is equal to total distance traveled by time. Total distance is the circumference. What is the equation? 2 pi r. 2 pi into r divided by time. Here we take the time as t, capital letter T, because it's the entire circle. It's a simple thing, simple equation. Maybe 1 or 2 marks numerical will come from this part. Okay. So in the case of uniform circular motion, what is the speed? The total distance traveled divided by time. The total distance traveled is, the entire circle is the circumference of the circle. Okay. When the questions comes, only half distance traveled means you don't want to add this 2. Only pi r is the value. Okay. So time you already know, r you already know, distance you can find it out as 2 pi r, then you will get the speed. But in the case of this, how we can find out velocity? Let's see, we studied that speed is a scalar quantity, isn't it? So it does not have direction, it only has a value or magnitude. But in the case of circular motion, each and every time that particular body, if this body is rotating in the circle, each and every time the body is changing its direction, isn't it? When it is here, the direction is what? This is the direction. When it is here, what is the direction? This is the direction. When it is here, this is the direction. When it is here, this is the direction. Here, this is the direction, isn't it? So each and every second it is changing the direction. So it is very difficult to find out velocity because each and every time velocity is changing. So velocity never remains constant for circular motion. Okay, it is very difficult to find velocity in the case of circular motion because if we go for these directions, infinitely time it is changing. Understand? Infinitely time the direction is changing during uniform motion. Understand how the direction is changing? When the body is here, the tangent drawn to a circle gives its direction. So for uniform circular motion, the direction is changing every time, so it is very difficult to, not very difficult, it is impossible to calculate this velocity. Okay, this is also a very small part regarding this chapter, and that's the end of this chapter. Numericals are the main things. Okay, numericals are the main things. These three equations of motion, by heart it, like even if from sleep somebody asks, you must answer it. Okay, from here to the future, you must have these equations. The next chapter we are going to study is the about laws of motion and all that. Chapter also is the continuation of this chapter. Understood? So keep it in mind. I won't explain it one more time. Okay, I know physics is difficult and 9th standard physics is more difficult, but I think I at least explained it 3 times. Okay, 3 times is not a simple time. Okay, I hope all of you are fine, isn't it? Okay, my dear kids, that's it. That is the end of this headache, isn't it? Is that chapter a headache? Anyway, the next headache is coming on. The next chapter is more headache than this chapter. Okay, now if you understand the concept and solve the equations like this, it will be easy. Next chapter, this much derivations are not there. Okay, mostly the derivation part is over. In 10th standard also, that much derivations are not there. Very, very small derivations. This was the particular derivation which has a lots of concept in it. Especially that scalar and vector quantity is very difficult to understand. Okay, so these are the things we have. Okay, circular motion also, only just this equation you want to study. What is P? 2 pi r divided by t. Okay, so that's it. That's the end of this chapter. I will give some numericals as homework, and if you have doubts or just try to solve it. Okay, just try to solve it and send back the answers. And you can also refer the textbook numericals. Okay, textbook numericals are there that you can directly write into your science notebook. Okay, but first what you want to do, you want to write that notes. The notes are very important regarding this chapter. I know it's too much, but try to write it out. Taking printout means it's easy for you, but whenever you are writing with hand, you will understand more. Okay, that's the simple theory regarding education. Okay, so I hope the class was interesting and physics was an easy subject. At the beginning time it was a bit difficult, now I think it's a bit easy, isn't it? Okay, my dear kids, this is Mr. Raj signing off from this part of the world. We know that Corona time. Anyway, we will survive it soon. But till then, stay at home, stay safe. Okay, when you are getting out means wear mask and all, and be safe. Health and hygiene and our willpower is the better weapon against this pandemic virus called as the COVID-19. So, my dear kids, have a nice day, have a nice study time regarding physics, and just revise it daily. Okay, for at least for a week, just revise it daily. 2 or 3 days we will continue with numericals. Not 2 or 3 days, 2 days we will continue with numericals. After that we will start the next chapter. Okay, till then, goodbye. See you soon. Bye bye guys, and Jai Hind.